Rock, report range status.
The range is green.
That is a
Hey
great
guys, Bottom
sign that your
25 here.
range is green, Darryl, that we are good to go.
Watch launch of Landsat 9.
Coming up on that pole from Launch Conductor Scott Barney.
40. Stable at step 3. $25.
Status check. Go Atlas.
Go Centaur.
Go Landsat 9.
And there it is, the word to launch Landsat 9.
T-minus 15.
T-minus 10.
9, 8,
8,
7,
7,
6,
6,
5,
5,
4, 3, 2, 1. Engine
ignition. And
And
liftoff of the
liftoff.
Atlas V 401.
Liftoff of an Atlas V rocket and Landsat 9, continuing the legacy of an irreplaceable 50-year record on our ever-changing planet.
Control system response looks good. RD-180 engine operating parameters continue to look good. Vehicle has begun the pitch over maneuver. Body rates look good.
That pitch over maneuver heading it to the south towards Southern California and down to Mexico.
Now passing 40 seconds into flight. Engine operating parameters continue to look good. Pump speeds and injector pressures all within expected ranges.
There's a shot from our tracker cam above the marine layer.
Now 55 seconds into flight. Vehicle is now completing the pitch over maneuver. Body rate responses continue to look good. 3 minutes remaining in the boost phase of flight. Pump speeds and injector pressures on the RD-180 continue to look good. Body rates continuing to look good.
Everything's going good. So this is for...
And at 1 minute 20 seconds into flight, Atlas is now supersonic, vehicle passing Mach 1.
There we go, so max
Critical
Q there.
moment for the rocket.
And vehicle is now passing max Q, maximum dynamic pressure. RD-180 performance continues to look good throughout boost phase. Engine's now throttling down slightly as expected. Engine response looks good.
That throttle down reduces the stress on the 19-story tall
At
vehicle.
1 minute 50 seconds into flight, vehicle is now 10.7 correction.
Because of course
13
max Q
miles
is
in altitude,
maximum aerodynamic pressure.
7.9
Maximum dynamic
miles
pressure rather.
downrange distance,
It's maximum
traveling
aerodynamic
at
force on it.
1,500 miles per hour. Now just under 2 minutes remaining in the boost phase of flight. At 2 minutes 18 seconds, the Atlas V vehicle now weighs just 1/2 of its liftoff weight. And vehicle's gone to closed loop guidance. Body rates indicating a slight adjustment can be expected for this phase of flight.
There's a beautiful shot right there, looking back towards the planet. And see the plume from the RD-180.
The plume is spreading as
And the
the
reaction control
atmosphere
system
pressure
on the
around
Centaur is
it
now pressurizing
decreases
flight levels. System pressure response
as it gets
looks good.
higher. Okay, the
The
plus
reaction
1 miles
control
in
system on
altitude.
Centaur, they're prepping it.
RD-180 engine operating parameters continue to look good throughout boost phase. Body rates remain stable.
Coming up in 60 seconds, the
Now
booster
passing 3
engines will
minutes
cut
into
off.
Flight. Approximately 1 minute remaining now until booster engine cutoff.
Our tracker shot getting a great
And now 3 minutes 15 seconds into flight. Atlas is 48 miles in altitude, 70 miles downrange distance, traveling at 5,600 miles per hour.
shot as it goes out over the southern Pacific.
Pump speeds and injector pressures on RD-180 continue to look good throughout boost phase.
Okay, we're approaching booster cutoff there. Booster engine cutoff for BECO.
And the Atlas V is now throttling to maintain a constant 5G acceleration limit. Engine response looks good.
Speed currently 7,700 miles per hour.
Has begun boost phase chill down. Now throttling to maintain a constant 4.6G acceleration limit in preparation for BECO.
This is where the booster engine cuts off and then separates.
And we have BECO
There's
booster engine
BECO.
cutoff standing by for stage set. And we have good indication of Atlas Centaur separation. We have pre-start on the RL-10, standing by for ignition.
And there you see the separation.
And RL-10
We have
ignition.
ignition and full thrust on the RL-10. Chamber pressure looks good. Body rates look good.
Beautiful shot of the booster falling away as you're looking
And we have
down.
good indication of payload fairing jettison.
And you should see the
This
payload
first burn
fairies.
today
Sometimes they
will
come around the
approximately
side.
12 minutes, 11 seconds.
There you see one.
RL-10 performance continues to look good in the early part of this first burn. Now passing 4 minutes, 47 seconds into flight.
So we're in a good point, Mick. Flight is looking good. We're going to monitor the situation here. But what a beautiful launch. What a beautiful flight so far.
5 minutes.
But there's still a lot of work to do.
Yeah, absolutely. A lot of work to go on, but beautiful shot there of the RL-10 engine in space, sending Landsat 9 onto its orbit. A great launch this morning. So excited for this.
We're getting some of that orbital sunrise on the engine bell there, and that's just a neat look as you look back at our planet. All right, Marie, we'll keep track of things in here, but for the meantime, we'll send it back out to you on the hill.
All right, thanks, guys. We did get lucky enough for that marine layer to clear so we could see liftoff from here at the gravel pit. Earlier, I had the opportunity to speak with NASA Administrator Bill Nelson about today's launch. Take a listen. NASA Administrator Bill Nelson, thank you so much for joining us. You have described climate change as an all-hands-on-deck global challenge that requires action now. Tell us, how does the Landsat program help leaders take action now to address climate change?
We best get on the business of doing it right now. And what Landsat does, it is the longest continuous global satellite record of the Earth's surface. And these satellites have documented Earth's changing landscape. It helps farmers, scientists, understand and manage land resources, and all of that is needed to sustain human life. Such things as food and water and forest. And of course, Landsat's long-term record of our home planet allows us to track the changes and the impacts of climate change.
And President Biden's fiscal year 2022 budget requests $24.8 billion for NASA. That's a 6% increase from last year, and also the strongest budget NASA has ever had for science. How do you quantify the value of NASA's science missions?
It is a very strong budget request. The value is immense. And when you're talking about data like this, it's hard data that arms decision makers with the tools they need to make tough decisions about our future. It's exploration on other planets, helping to answer the age-old questions. How did we get there? Are we alone? It's the inspiration of the next generation. That is what this science budget is all about.
And besides Landsat, in what other ways is NASA making it a priority to understand and respond to climate change?
Well, we are doubling our efforts to lead when it comes to climate science. Earlier this summer, we announced a new Earth Systems Observatory. It's going to be 5 great observatories that will look at the land, the oceans, the ice, and the atmosphere, and combine a 3D composite of what is happening very precisely to our atmosphere. That, combined with all of our other existing assets, such as the Landsats, it's going to develop the ability for us to really measure what is happening. And also, we're continuing to develop resources for sustainable aviation. That is less pollution in the air from aircraft. and it will keep industry in U.S. competitive and drive fuel efficiency that helps the environment.
Administrator Bill Nelson, thank you so much for your time.
Thanks a lot. Have a great day.
All right, there is a live view on your screen now of Landsat on its way into orbit. Turning now to one of the many practical applications of Landsat, the U.S. Department of Agriculture uses it to track annual yield of every crop grown in the United States. Disaster managers can see impacts from floods and other natural disasters. Resource managers can use the data to direct crop rotation and monitor water use. Take a look.
America has always been a fertile land. Grasslands and forests and farms, from sea to shining sea. The U.S. Department of Agriculture tracks how many acres and the annual yield for every crop produced. From the big ones like corn, wheat, soy, to regional crops like cotton, rice, citrus, they track every year using data from Landsat satellites and others, combined with data from surveys on the ground. Landsat satellites see detail at the human scale, about the size of a baseball diamond, and can image individual farm fields. The program started in 1997 with North Dakota as an experiment. Other states became interested, and the program grew. In 2008, Landsat data became free to use, and the USDA could afford to map 48 states. During the growing season, the data helps estimate crop yields, which helps farmers and traders set prices for the harvest. Thanks to Landsat's detailed view, the USDA tabulates stats crop by crop, county by county, and state by state. At the end of each year, the data set is released to the public, and it is a beautiful sight. The patchwork of corn in yellow and soybeans in green in the Midwest. The diversity of crops in California's Central Valley. The clusters of citrus in Florida and California and Texas. We can see changes in farming through the years. The easiest to see is crop rotation in the Midwest, cycling between corn and soybeans. In northern North Dakota, there is a shift from barley and wheat to soybeans and canola. And we see an increase in cotton fields, shown in red, in Texas and Oklahoma. Thanks to the free and open access to Landsat data, the U.S. Department of Agriculture is providing our farmers with accurate data and helping maintain our nation's food supply.
All right, we want to bring in a special guest now from Northrop Grumman, the company that actually built the Landsat 9 satellite. Frank DeMorrow, you are the Vice President of Tactical Space Systems for Northrop Grumman. And I understand this was your first launch out here at Vandenberg. How was it?
It was really special to see that rocket lift off.
Yeah, well, I tell you, we got a little lucky. It's also my first one, so we shared that together. But the last couple of days, the marine layer has been so thick, it's been very hit or miss, our view from here to the launch pad 4 miles away. So we lucked out. I'm glad you got to see it lift off.
Yeah, it was a special time. Special time.
So this is Landsat 9 is the 4th satellite that Northrop Grumman has built for NASA. Tell us about the process. What goes into building a Landsat satellite and integrating it with the instruments?
Yeah, well, of course, the satellite that we build, the platform part of it, is really there to carry these special instruments to do the work that Landsat 9 is going to do. And so we have a dedicated team of engineers in Gilbert, Arizona, where we actually designed and built the satellite, working closely with our NASA customer to make sure that the structures and the power and all the data transfer systems are all in place to be able to accommodate the instruments. And then once we put that all together and put the instruments on the spacecraft, it goes through a rigorous test process. So that when we deliver it here and it gets launched like you saw today, it's ready to go.
There are so many things, as you know, that have to go right for a rocket launch to happen. And certainly the workers that you described in Gilbert, Arizona are a big part of that. All of the meticulous work I'm sure they had to do to get to this point. Can you talk a little bit about that team, what it's been like working through the COVID pandemic and any impact that's had at all?
Well, it's a really special team, and they're so dedicated to this mission. The fact that this is our 4th Landsat mission, partnering with NASA all these years in this type of mission is really special, and the team understands that. And as they've worked through the past year and a half, they've just continued to work through the COVID period, being dedicated to this mission, knowing what it really means to NASA, what it really means to the nation to get this data down to the ground. So they've persevered, they've worked really hard, and I'm really so proud of them. Mainly, that's the main thing I'm most excited for today, is what the team gets to see.
Well, congratulations to you and the Northrop Grumman team.
Well, thank you very much. Appreciate it.
You're welcome. Thanks for being here. All right, we are now at launch plus 14 minutes, 37 seconds and counting. We expect Landsat 9 to reach orbit, its intended orbit, in just a few minutes, and here's some things to know about that. It will circle the Earth at an altitude of 438 miles. It will travel at 16,760 miles per hour, or 4.6 miles per second. Each orbit around the Earth will take 99 minutes, so Landsat 9 will complete 14 orbits per day. Landsat 9 will take more than 700 pictures of Earth every day.
By higher
All right, and as I mentioned, we are approaching that orbit milestone, so let's get over to Darryl and Mick to take us through the next few minutes. Guys?
That's right, Marie. We are just seconds away from main engine cutoff. Centaur has been burning now for several minutes. It's really close. When this happens, we're going to be in an orbit that's a little bit higher. You just heard we're just about a minute out.
Yeah, so what's happening is we have this first burn, and we're trying to get a slightly lofted orbit this morning into that near-polar sun-synchronous orbit, Darryl, so that we can get Landsat 9 up there. What will happen is main engine cutoff will occur, and then we will coast for several minutes to get Landsat 9 into the orbit it needs to be, and then we will get spacecraft separation at L plus 1 hour and 20 minutes.
Hard to believe we're just a few seconds away from main engine cutoff, but hard to believe this spacecraft and this rocket have gone almost completely around the planet. Currently coming up through eastern Africa, over Turkey. We're just seconds away. Let's listen in to the call for main engine cutoff.
Homie, you're over the ocean.
And we have MECO, main engine cutoff.
There we go.
Body rates look good. Vehicle is now recovering from the shutdown transients.
And there you go, Darryl. We heard from United Launch Alliance commentator Patrick Moore, who's done a fantastic job since liftoff of filling us in on all the activities that have been going on, and we just got confirmation of main engine cutoff. So Landsat 9 and the Centaur will coast for a little bit, and then we're about 1 hour and 3 minutes from Landsat 9 separation.
Yeah, it'll coast for a lot of bit, right? Because as you can see in the bottom of the screen, we have removed our progress bar with the milestones and now have a new progress bar, which will show you the time to spacecraft separation, which you can currently see is set at 1 hour and 3 minutes. We'll be monitoring everything here, but once again, we'll send it back out to the hill with Marie.
So I'll pause the video here so you
thanks, guys.
see
Joining
for
me now is
spacecraft
Landsat
separation.
9 project scientist Jeff Masick. Jeff, thanks